In today's class, we are going to be looking at determinant of 2 by 2 and 3 by 3 matrices. So under this topic, we'll be looking at these objectives. The first objective is brief explanation of determinant of 2 by 2 and 3 by 3 matrices. So the second one is examples on determinant of 2 by 2 and 3 by 3 matrices. So starting with the first objectives, which is the brief explanation of determinant of 2 by 2 and 3 by 3 matrices. So let's start with the determinant of 2 by 2 matrix. So determinant of 2 by 2 matrix can be determined if A is a 2 by 2 matrix given as A, which is equal to A11, A12, A21, A22. So we have the first row, we have the second row, first column, second column. So this matrix A is 2 by 2 matrix because the number of rows is equal to the number of columns. So to determine the determinant of these matrices, so the determinant is denoted by that A or absolute value of A. So this is the representation of determinant of 2 by 2 matrix. It's either we have it as that A or absolute value of A. And this represents, so we have that A, which is absolute value of A. Then we have A11, A12, A21, A22. So this is determinant of matrix A. So to simplify this, we are going to multiply the principal diagonal, the element in the principal diagonals together. So we are going to multiply the element in the other diagonal. Then we now subtract the multiplication of the element of the other diagonal from the multiplication of the element in the principal diagonal. So we have it as A11, which is the main diagonal or principal diagonal. So A11 multiplied by A22 minus A12 multiplied by A21. So which is equal to A11, A22 minus A12, A21. So this is the simplification of determinant of 2 by 2 matrix. So we have the main diagonal, which is the principal diagonal, and we have the other diagonal. So to simplify or to determine the determinant of 2 by 2 matrix, we multiply A11 by A22, so we have this, then minus A12 multiplied by A21, we have this. So this A11, A12, A21, A22, they represent numbers. They represent numbers. So we can use number in place of all these A11, A12, A21, A22. So this is just a simple explanation of determinant of 2 by 2 matrix. So we are going to solve a question under this determinant of 2 by 2 matrix now. So we have example 1. So question number 1, example. So example 1 says if matrix F is 2, 4, 3, 8 and matrix F is minus 5, minus 1, 4, 2, determine determinant of M. B, determine the determinant of N. C, determinant of M plus determinant of N. So to do that, let's start with A. So question A says determinant of M. So we have matrix M to be 2, 4, 3, 8. So determinant of M is given as determinant of 2, 4, 3, 8. So the element in the leading diagonal or principal diagonal is 2 or are 2 and 8, while the elements in the other diagonal are 4 and 3. So we are going to subtract. We multiply the element in the principal diagonal, which is 2 multiplied by 8, then minus 4 multiplied by 3. So which is equal to 2 multiplied by 8, that is 16, minus 12. So 16 minus 12 gives us 4. So it means the determinant of matrix M given as 2, 4, 3, 8 is 4. So for the second question, which is the B part of the question, determinant of N. So determinant of N, what is matrix N? Matrix N is minus 5, minus 1, 4, 2. So determinant of N will be determinant of minus 5, minus 1, 4, 2. So which is equal to, so multiply the element in the leading or principal diagonal. So this one, we have minus 5 multiplied by 2, then minus, then multiply the element in the other diagonal. That's minus 1 multiplied by 4. Multiplied by 4. So which is equal to minus 5 times 2, that's minus 10. Then minus 1 times 4, minus 4. So which is equal to minus 10. Minus times minus is what? Plus. So plus 4. Minus 10 plus 4 gives us minus 6. So the determinant of matrix N is minus 6. So the next thing to look for is to look for question C, which says determinant of M plus the determinant of N. Now, so question C says determine the determinant of M plus the determinant of N. That is answer to question A and B. We are going to add the two together. So the determinant of M from question A, that is determinant of M plus determinant of N. So what is determinant of M from question A? That is 4. So 4 plus determinant of N from question B, minus 6. Minus 6. So which is equal to 4 plus times minus is what? Minus 6. So 4 minus 6 is what? Minus 2. So this is the answer to example number 1 under determinant of 2 by 2 matrix. So thank you. We move to the next one, which is determinant of 3 by 3 matrix. So after the determinant of 2 by 2 matrices with example, so we are, I'm trying to explain the determinant of 3 by 3 matrices. Determinant of 3 by 3 matrices. So let A, that is a matrix A, given as A, B, C, D, E, F, G, H, I. Then the determinant of A, given as that A, or absolute value of A, is written as determinant of matrix A. So to determine the determinant of these 3 by 3 matrices, or these 3 by 3 matrices, we are going to hold on to the first row, or cover up the first row and the first column. So for the first element, so we have A, then hold on to row and column along A. So we are left with E, F, H, I. So that is the first one. Then the second, so we are going to subtract. We have plus, minus, plus F. So the second form, we have minus B. Then hold on to the row and column along B. So along B, hold on to row and column along B. So we are left with D, F, G, and I. Then the last element, C, on the first row. So you hold on to C along the row and along the column. So we'll be left with D, E, and G, H. D, that is plus E, plus C. Then hold on to C along the vertical and along the horizontal and the vertical. So we'll be left with DE, then GH. So this is how we are going to simplify. Then from here, we are going to have A, so which is equal to A into, you multiply the principal diagonal, that is E times I, EI minus F times H, that is FH. So we are done with the first one. Then the second one, minus B into D multiplied by I, that is the element in the principal diagonal, DI minus FG, then plus C into D multiplied by H, D multiplied by H, then minus E multiplied by G. So this is the simplification of determinant of 3 by 3 matrix. So we move to the example now. So the example says, example 1 under determinant of 3 by 3 matrices. So the question says, evaluate the determinant of matrix M, which is 2, 5, minus 6, 3, 0, 4, and 3, minus 1, minus 2. So to determine this, we are going to start by writing out by bringing down determinant of M, which is determinant of 2, 5, minus 6, 3, 0, 4, 3, minus 1, minus 2. So which is equal to, so the first element in the first row, so we are going to use cover up method. You cover 2 horizontally and vertically. So we have 2, then we'll be left with, if you cover 2 vertically and horizontally, so you'll be left with the 0, 4, minus 1, minus 2. Then minus, because we have to label this as plus, minus, plus. So minus 5 into the determinant of the remaining 4 elements. So when you do cover up method, so you cover 5 horizontally and vertically. So you'll be left with, if you cover 5 vertically, you cover this, everything here, then cover everything here. So you'll be left with 3, 4, then 3, minus 2. So this is for the second element. Then the third one, plus, minus 6. So we have minus 6 there. So it's supposed to be plus, then with minus 6. Then we have, so using cover up method, so we cover 6 horizontally and vertically. We'll be left with 3, 0, 3, minus 1. So we now simplify this. So which is equal to 2 into, to multiply the principal diagonal, that this is 0 multiplied by minus 2, that's 0, then minus 4 multiplied by minus 1, that's minus 4. So that's the first one. Then minus 5 into 3 multiplied by minus 2, that's minus 6. Then minus 4 multiplied by 3, that's 12. Then plus times minus is minus, so minus 6 into bracket 3 multiplied by minus 1, that's minus 3, minus 0 multiplied by 3, that's 0. So which is equal to 2 into 0 plus 4 minus 5 into minus 6 minus 12, that's minus 18. Close the bracket. Minus 6 into minus 3. So which is equal to 2 into 4 plus 5 times 18, that's 40, 0, 5 times 8, 40, 0 carry 4, 5 times 1, 0 carry 4, then 5 times 1, that is 5 plus 4, that is 9, making 90. Then minus times minus plus 6 times 3, 18. So we'll be left with 8, that is 2 times 4, 8 plus 90 plus 18. So which is equal to, that's 116. So the determinant of this 3 by 3 matrix is given as 116. So question number 3. The question says if determinant of this matrix, that is 3, 2 minus 1, 4, 1, 1, 1x3 is equal to 2. Find the value of x. So to get the value of x is to determine the determinant of the left hand side. So we have it as, so you first label the column as plus, minus, plus. So we are going to hold on to 3, that's plus 3. Then we'll be left with, so hold on to 3 along horizontal and vertical. Along horizontal and vertical, you'll be left with these 4 elements here. So we have 1, 1, x, 3. Then the second element in the first row, that's 2. So we have minus 2 and 2. So hold on to 2 horizontally and vertically. So we'll be left with 4, 1, 1, 3. 4, 1, 1, 3. Then plus the last element there, that's minus 1 in the first row, minus 1 and 2. So you are left with 4, 1, 1, x. 4, 1, 1, x. So close the determinant equals to 2. So we now simplify further. So we have 3 and 2. Multiply the principal diagonal, that is 3 times 1, 3, minus 1 times x, x. Then minus 2 and 2, 4 times 3, that's 12, minus 1 times 1, 1. Then plus times minus is minus 1 and 2, 4 times x, 4x, minus 1. So that is 1 times 1 minus 1 equals 2. So you can open the bracket and simplify. So 3 times 3, 9, minus 3 times x, 3x. 12 minus 1, that's 11. 11 times 2, that's minus 22. Then minus 1 times 4x, that's 4x. Minus times minus plus 1 times 1, 1 equals 2. So the next thing to do is to collect the like term. So we have minus 3x minus 4x equals to plus 22 minus 9 minus 1. So we have minus 7x equals 22 plus 2, that's 24, minus 10. So we now have minus 7x equals 14. So you divide both sides by minus 7. So we have minus 7 x over minus 7 equals 14 over minus 7. So this cut this s equals minus 2. So the value of x is minus 2. So what you are saying is, if you put minus 2 here and find the determinant of this matrix, you are going to get 2 as your answer. So thank you and God bless you. So please subscribe to the channel and give us the thumb up. Thank you.